off by default, as it should be, so that when you open it up in an IDE that supports C#8, it doesn't show you a gazillion warnings and you get overwhelmed. If you create a new project in this hypothetical IDE that supports C#8, the feature should be turned on, because it's brand new code, might as well write it correctly from the start. So intentionally we're deciding when it should be valid to be on and when it should be valid to be off. Next, you go to the gazillion lines of code and you go, okay, let me turn it on, and oh my goodness, that's too much, and I turn it off. That's still too much. We need to figure out what is the knob, and where do we put it to say we turn it on? Do we put it on at a library level? Do we put it on a class level? Do we put it on a method level? What is the deal with where we're going to put that? And so there's an attribute that's just emerged not too long ago. It's called the Nullable Reference. Not null types. And so you can decorate at various levels within your source code to say, hey, start with this class, let's make this not null types, and then this class supports that, and I can check it in, and I can make sure when I check it in, this class has handled the scenario. Or I can go to method and say, let's set it up for this method. And so you can sort of dial in at what level you want to opt into this feature, rather than being the default. But by default, new projects, it's on, and existing projects, it's off. That's the default.
Hypothetically, what other things might you be able to decorate that way in addition to modules?
Classes and methods. The methods I'm not sure about, because I'm not sure if that happened, but we can definitely do it at class level. So it turns out that this is a great feature, but if you're interacting with C#7, it doesn't know about nullable reference types, or the fact that by default a value could be declared as well as not nullable and not nullable. And so we have a scenario, and if you looked at this code, you could say random value generator there. This is a different project. It's a C#7 project. Sorry, pre-C#8, just to be same thing. And in this case, it goes ahead and returns a string. But I'm programming in C#8. And if you return a string, that means it's not null. But I'm programming against a library that is C#7. And I don't know whether what's going on. And so I can't actually rely on the data being returned. Even though I declared it a string, it said it was returning a string, and I got to go in and handle the scenario. Right? So backwards compatibility, as we start to do interop between 8 and pre-8, is going to get gnarly. And this is the scenario that's really interesting, because if you go back to hold on, let's semantically change it. In this case, we wouldn't have checked for null, and we should have checked for null. And so we're not allowing you to be lazy, because there are many, many scenarios where ignorance is not bliss. Right? And you really do need to think about, okay, who am I interoperating with? What am I compiling against? Now what we can do is we can take a C#8 compiler and we can add attributes that say, oh, this was compiled with C#8. And therefore, you can rely on it. Or not. Because what if the warnings were ignored? What we're trying to do is enable you to program better. And at least be notified when you are making a mistake. What we are not doing is guaranteeing that whoever you're invoking or whoever is invoking you is perfect. Or giving any sense of such. We are simply allowing your code to be better. We are not allowing you to assume or presume anything about those who are invoking you or you are invoking. So it's a great feature for improving your code. It is not an ideal world where everyone's code suddenly becomes perfect. Over time, assuming this is turned on, we don't overwhelm you with warnings, more and more people will start to do this, and they'll go ahead and change the code to turn warnings as errors, and we'll get better and better code, such that we live in a world where no null reference exceptions occur.
question.
Yes.
What's the difference between string and string bang?
Sorry. Right here?
102.
Yeah. So notice that this is commented out. If we had the ability to do this, there's not. Basically, I'm saying there's the concept you could have three. If we didn't do this right, we could have three different types. We could have nullable reference types, we could have not null reference types, and we could have I don't know types. It turns out we didn't do the string bang because what was the point? And I should probably put this. I should put this method first, right? Just to introduce all sorts of we wish and realize it doesn't make sense. However, there are scenarios where you want to say, trust me, I'm a programmer. And the way to say, trust me, I'm a programmer, this is null, not null, is to use a bang. So you could go ahead and say, text bang dot, which is different than text question mark dot. If I say text bang dot, I'm saying, trust me, I'm a programmer, I know this is not null. And this becomes important because it turns out there's a bunch of scenarios that the compiler doesn't know how to handle. For example, this one. If I use an object reference equals, static analysis doesn't know I'm comparing it to null. Because object reference equals could compare to anything, right? So, and this could, again, this could be an expression that is, who knows how many lines of code complicated, we don't know. So, reference equals, we don't go in and say, well, reference equals is also a null check. Now, it turns out there was a special reason that I chose to use reference equals here, blah, 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 blah. And when I do that, then I need to have the ability to say bang, text bang, dot, which means, trust me, I'm a programmer, I know this value could not be null. And so there is a way for you to override the compiler warnings to say, yes, this time it will not be null. Now, of course, at runtime, we're still checking. We're still going to throw a null reference exception if you aren't trustworthy. But you can tell the compiler you trust at compile time, and we won't issue a warning.
So would the bang go on line 157 after text?
Yes.
Okay. Sorry.
No, it's fine. I have a better example. The answer is yes. I was hoping to find an example where I did that. Okay, other questions? Okay, here's one for you guys. What is text 1?
Or you mean what type is it?
Yeah, what's the data type?
String question mark?
So you're setting bar text lines that get nullable reference type, and then right after that you're setting it null.
It is a string question mark? Nullable strings?
How do I know? The question mark, and so the way to know what value of the var is you look at the return of the right side. The return on the right side is a t question mark, where t is a reference type based on the constraint that it's a class. So I'm saying t question mark, this is therefore a reference type, but it is a nullable reference type. And then I'm going to go ahead and assign var to be a string question mark. And the way it's determined what the var value will be is by looking at the return of the member you're calling, or looking at the return of whatever is assigned the first time. Notice also that, of course, nullability propagates into generics. And so you can go ahead and use the question mark, in this case in the generic, because it propagates. However, underneath the covers, it's just a string. A string with an attribute. Actually, there's no attribute in this case, right? There's no need for it. It's inside my own method. There's no public API. You only put attributes on when you got public APIs. If there's no public API, no need for attributes. It's all internal. Okay, any more questions on nullability? Yes?
Isn't it better to crash and die, than to do all this?
Probably not if I'm riding in an airplane. Okay, so the question was, isn't it better to crash and die than to do all this? Thoughts? What do you guys think?
No, I think you're right. I think there's a flaw, then we're doing the wrong thing by default. I hope that this is not going to break things, but you are right about that.
That it's better to be in denial?
No, I don't agree with that.
Oh.
Of course not. We're all dealing with it.
I think this is the reality. When you open up your existing code and you turn on this feature, you're going to have a heck of a lot of work to do. Now, if you have already checked for null like you should in your existing code, you aren't going to see a warning as long as you didn't do like reference equals or something weird, bizarre. Right? If you simply check for null using an is null or equals equals null, if you do that check, we're not going to show a warning. And if you didn't do that check, you either know something about the code, in which case you're saying, trust me, and you can use bang, or you should be fixing it anyway. So, in response to your question, right, shouldn't we crash and die anyway? It turns out that every single time that you throw this exception is a bug. I would much prefer to have the compiler give me a warning suggesting that I fix my code than for my customer to see, no matter how pretty it is, null reference type exception. And I wouldn't be hazard a guess. It'd be way better for me to get to see that before my customer does and to improve my code than it would be for me to crash and die.
Just to add, it probably will give like a bad, example where if it is string, people will go and create a constant which will say is an empty type.
Yeah. Well, so your concern is wouldn't this cause people to just go ahead and assign string text when they initialize it to go assign it a value? And so instead of assigning it null, they'll go assigning an empty string. And therefore, at least when they dereference this, now it's still a bad type, it's just a different bad type. It's still a bad value, it's just a different bad value. But the reality of it is, at this point, so let's talk about your existing code today. The reason you assigned null was not because null was the right value. You assigned null because you want to get rid of a compiler warning.
Right. Yep.
I'm serious,
Yep.
right? That's why we did it.
Not in the case of strings. At least I don't.
Maybe not you guys, but somebody sitting next to you.
No, but other objects, not strings.
So fair enough. So the comment was, well, maybe not with strings because we could assign a value. But I think more importantly, I don't think null or empty string is necessarily the right solution. The right solution is to check. So if you take your existing code and you want to write it and make sure it will support C#8, check. Now, you can't go ahead and put a bang to say, trust me, I'm a programmer. But you can go ahead and put a statement in that says, just check. Is this value null? So in your existing code today, you can prepare yourself so that now when you get, say, hey, this variable is not being initialized, instead of going ahead and doing this, you can at least check for null. And then you can assign it whatever you like. And if you do check for null, then at least when you go ahead and make that a nullable type or not nullable type, you're going to handle this thing. Okay, any other questions about nullable types? Yes?
How is reflection going to see that? Just as a string?
So,
or it will be able to differentiate?
String, the question was, what is the effect for reflection? And the answer is, on public APIs, there will be an attribute on your parameters, on your return values, on everything in the public API. In the private internal, no change. Because if it's a private method, we don't need to do anything. It's just for inside, like it's inside the method, you declare a type. No, there's nothing, I don't need to do anything. So we will add decorations, we'll add metadata only for the public interface. But internally we won't make any changes, yes?
Sort of related question. Are you planning to, or maybe considering using the JetBrains notations for that? Because I would guess that's what most people use right now for the
So the question was, am I planning on using the JetBrains notation? And I have, the answer is no, I'm not, but I'm not writing the compiler, so that's not really important. I don't believe there is any change besides what I have shown for doing, no. I know for sure that what I've shown here is the only notation we're specifying in the language.
Yes, but as a backend, I mean, it's clear that you are going to mention that.
There is an attribute. I think it's not. I don't think so. No, it's not the same as JetBrains because it's in our own assembly. So all we are doing is adding an attribute.
Yeah, the question is basically, could it be considered to use the JetBrains attribute instead?
That's in a different assembly. That's not part of .NET Core. So no.
Okay.
It's not because I'm objecting to JetBrains or anything they're doing. I'm just saying I need to have it be inside .NET Core.
Well, I mean, they are also probably open source.
The comment was that they're also open source, but I'm not taking a dependency on JetBrains inside .NET Core. Okay. I think I talked about all of this stuff here, so we're good to go. Okay, next. If you go ahead and declare, you can declare an array with a range. And then we have this fantastic syntax where if you want to go ahead and get the last item in the array, you would go ahead and do this. It's just, I mean, doesn't that look so pretty? I just love it when I have to go ahead and get the last item by doing array.length -1. I mean, it's just brilliant. I mean, it's so much better than like Python or PowerShell. What if we make it so much better? What if we did this? What if we could say new index 1, true? Come on, guys, this is good stuff, right? So it turns out you could do this, right? You can go ahead and write the index operator, and you can go ahead and declare a type called index, and you can go specify that 1 and count backwards, right? If this is false, it counts forwards, and if this is true, it counts backwards. Perfectly obvious, yes? Go ahead and tell me this isn't an improvement to the language. It turns out there's no language changes to support this. You can do this in your C#7 code today, and not with these data types. Well, you can get them, they're open source, but you just download them and include them. And you could do that. And then, I mean, this is way better, right? Way better. Or you could make a language change in C#8, and you could do that. Which says, go ahead and get the last element by going to the end and counting back 1.
Can you do anything on it? Like a -1 to get the second to last?
Yes! No, not -1.
+1.
No, hold on. Wait. I want to be clear. Can you go ahead and get the last 2? Of course, you go 2. Hat 2, hat 3, hat 4. You can count all the way back. So yes, we're not just going to give you the last element. We're going to say count from the end back. Yes?
Why not just use the minus?
Oh my goodness, what a brilliant question. Why not just use the minus sign like other languages? So in order, there are times, I just literally sat with the program manager for C# and asked this the question. And it was seriously debated, and you can go read the entire debate. It turns out it's open source, you can go read about it. But what does -0 mean? And it turns out minus 0 is 0, or do we actually count, or do we not make it an integer anymore? Do we change the interpretation of what minus 0 means? And remember, internally this is an index operator. I mean, you can go write an index operator. So if you do minus 0, it actually has meaning. You can just translate it to mean something. It turns out minus 0 is some item within the array that's indexed by minus 1, but minus 0 is 0, and so we're not sure how to do that. So it was debated significantly, and it was decided that the minus operator against an integer has meaning that we don't want to change, because it would be a breaking change to the implementation. So you could have existing code that had an index operator that used negative values, and you did something with them, and we don't know what it was. So on an array, what you're saying makes sense, but it turns out on your own types and index operators, that would be a problem. So this way we force you to say, no, you are taking a new index. You have to, if you're writing a collection yourself, you have to implement something that takes an index operator that takes a data type of index and handle that scenario. And so really it was a backwards compatibility problem. How did we introduce a negative number into an index where it's a valid integer, and we'd be breaking a change if we did that, or potentially breaking stage? Yes?
I don't understand the second one, the array new index by
Yeah.
classify.
Good question. So the question is, what's going on in the second set of code here? I want to be clear. At an IL level, this code is identical. These two. This one's not, but these two are identical. At a behavior level, all three are identical. But at an IL level, these two are identical. What we're basically saying is we can take, on an index operator, we can now take a data type index. And when you take the data type index, we will go ahead and take the first item counting back 1.